I'll just start the recording, 2 minutes. Okay, so in today's class, we'll see what is addressing mode and what are the different types of addressing modes. Yes, the screen is visible. I think yes, the screen is visible.
Yes, ma'am.
Yes. So addressing modes, what it is I had told that in an instruction when I am giving add instruction, add. Okay, and then I give the registers from where the which whose values has to be added. Okay, this example you have seen, I'm giving the registers whose contents has to be added. So what this operation, this instruction mean, add the content of R1 with the content of R2, and the result is put in R2. You had seen this format. Okay, result is put in R2, which is the register transfer notation of representing the instruction. This is the register transfer notation of representing this particular instruction. Now the content of R1 and R2 are added. Okay, so by giving this, when I give R1 here, the system knows directly that R1 content has to be added. Okay, now there are different ways in which the address of the operand, or from where the operand value must be taken, can be mentioned in an instruction. Okay, so the various formats of representing an operand, or the representing the location of the operand in an instruction, is called the addressing modes. Okay, so I think it is clear. Here there is an operand which has to be given along with the instruction. There are different operands which can be given along with the instruction. So how the operand can be represented, can be put in an instruction. Okay, so different ways in which the operands can be put is called the addressing modes. Okay, like if when you're doing the online shopping, you can pay the amount, like COD is there, cash on delivery, or you use the debit card to pay the amount. Okay, or you use the credit card to pay the amount. Okay, so there are different ways in which the payment can be done. Correct. So this similarly, there are different ways in which the operand can be mentioned in this particular instruction. Okay, when money transfer has to be done in the bank, there are different ways. There is RTGS which you can do, or you can give the check, or you can come and deposit the amount in a particular account. Correct. So there are different ways. Similarly, different ways in which the operand value can be mentioned in an instruction. Okay, is the addressing mode. Write down the various formats of representing operand or location of operand in an instruction. The various formats of representing an operand or location of an operand. You are giving the operand value or the location where the value can be present in an instruction is called the addressing modes. Okay, so there are different addressing modes. There is around 8 addressing modes in your syllabus. Other than this, depending on the assembly language which is used, okay, there are many more addressing modes, ways in which the operand value can be mentioned in an instruction. Okay, now this is register addressing mode. This is the addressing mode which you have seen already. Okay, so here what is done is the operand value is directly present in the register, in R1 register and R2 register. Okay, so the operands are stored in the CPU registers, and the CPU register value, which in whichever register it is present, that register is mentioned here. You can see the diagram. So this is the instruction, opcode, and register value. Okay, so what is this register? It is one of those registers, register set. Okay, Example is add R1 comma R2. Here two operands are used. R1 and R2 are two operands which is used, and both the operands are using register addressing mode. Okay. Operand is contained in the register set itself. Fine. So the content of R1 and the content of R2 are added. Correct? And where is the content present? The content is present in the register itself, R1 and R2. Next is direct addressing mode. So you have seen what is register addressing mode. Okay. So next we'll see direct addressing mode. In direct addressing mode, the address of the operand, the address where the operand is present, is mentioned in the instruction. Okay, so that is the instruction and the address where the operand is present. Okay, so operands are stored in memory location, and the name of the memory location is directly mentioned in the instruction. Fine. Now when I say move, okay, I'll use move location A comma R1. Okay, what does this location A mean? It is a location, it is the address of a memory location, okay, where the operand is present. So address of a memory location is mentioned here. Okay, and this R1 is register addressing mode. R1, this particular operand is using register addressing mode, and this operand address is given by direct addressing mode. Okay, a combination of direct addressing and register addressing and other index addressing, all this can be done. It is not only in an instruction. If it is there, it is not compulsory that it should be only direct addressing mode and only register addressing mode, nothing like that. Okay. Here in this example, this particular operand is using register addressing mode, whereas here location A is direct addressing. Okay, direct addressing means directly the address of the location of the operand is present in the instruction. Okay, now this is the location A in this example. Okay, in this diagram, this is the opcode, that is instruction what has to happen, and A indicates the memory location where the operand is present. Okay, so A, and you get this operand directly. Okay, you get this operand directly. Why I am telling directly is in a single access itself. So addresses here, directly go to that address and access this operand. Okay, note down the example. As I told, move, I am moving the content of location A to register R1. Okay, so how is the transfer notation? The content of location A is moved to R1 register. Register transfer notation of this particular instruction. And this is also called as absolute addressing mode. Absolute addressing mode. This is direct addressing. Any doubt? Okay, we'll see the indirect addressing. We'll see the indirect addressing mode. Okay, you have seen direct addressing where the operand address is directly present in the instruction itself. That is direct addressing mode. In this indirect addressing mode, the instruction contains an address. Okay, go to that address location where the address of actually where the operand is present. Okay, the actual address or the effective address. Effective address is nothing but the actual address where the operand is present. Okay, is given here. So in the instruction, the address which is mentioned is indirect addressing. I go to a particular location, and there in that location, the actual address where the operand is present is located. Okay, so it is not directly mentioned in the instruction. Fine. So this is indirect addressing mode. Now there are two ways of indirect addressing mode. There are two ways of indirect addressing mode. One is the instruction. In the instruction, the address what is mentioned is a memory location. So memory location's address is mentioned here. The other type is indirect addressing mode through registers, where a register value is given, and in this register location are the effective address of operand is present. Okay, so you can take this as the address you are giving. You suppose somebody was staying for rent in a different house. Okay, so this rent house address is given. Okay, so rent house address is given for some bank purpose or something. Okay, now you have shifted to separate different location, that now you are staying actually at a different location. Okay, so that letters which go to the rent house will be forwarded by the owner to you, correct? So it is not directly reaching to you, it is reaching to you via somebody else. Fine. So this is indirect way. Indirect address is mentioned in the operand value. Okay, how do the program know that is indirect addressing or the direct addressing which is mentioned here? Is you can see the way of representing indirect addressing. Suppose I use the same example. So add the content of A. Okay, the content of A and R naught. Now, if I give A, the content of A, or it is called as direct addressing. When I put within the bracket, means content of A is giving the address where the operand is present. A gives the address where the operand is present. Okay, so the content of A is giving the address, and that address content will give the location where the operand is present. Okay, once again, listen. So indirect addressing mode, address is not directly mentioned in the instruction. Address is given, address of a different location is given here in the instruction. In that location, in that content has the address where the actual operand is stored. So here it is the actual address where the operand is stored. Okay, the letters is not directly reaching to you. The letter address what you have given is some other person's. It goes to that person, and the person who is here in this address gives it to you. Okay, so this is indirect addressing. There are two ways of indirect addressing. Indirect addressing mode through memory location, that is memory location address is given here in the instruction. Okay, add A, okay, A content or not. So this is memory addressing. Memory address is given here. The other type is registers are used for indirect addressing. That is the indirect address what is given here is of register values given. Okay, and this register contains the address where the operand is present. Fine. So indirect addressing note down the actual address or the effective address of the operand, the actual address or the effective address of the operand is stored in a memory location or a register. Full stop. The memory location or register value is given in the instruction. Okay, so here this is indirect addressing through memory location. Okay, means memory location address is given in the instruction. Okay, now this is the memory. This is primary memory. In this you can see something as mentioned. Now what it is this is the instruction of the program. This is the program. Okay, and this is an instruction which is used in the program. There is a location A which is mentioned here. Okay, that is this location in memory. And this there is some location B which is mentioned, that is this, which is location B in memory. All these are in memory. As I told in the initial classes itself, in memory, the instruction and data will be present at different locations. Okay, the instruction is nothing but the program. Now, add A, you can observe here, it is not directly add A comma R naught. A comma R naught anta idre. It is the content of A is added with content of R naught. Correct? Now here you can observe it is put within the bracket, means it is indirect addressing what is done in this instruction. This is an example of instruction of in a program. Indirect addressing is followed here. So the content of A gives the address where the operand is present. Okay. Now what has to be added if it is this instruction? What content has to be added? A's content will give the address where the actual operand is present. Okay. And that operand's content is added with content of R naught, and the result is stored in R naught. Okay, it is not directly add A content and R naught content. You are not directly adding the content of A. No, you are not directly adding this content. Okay, you are adding this is giving the effective address. Okay, and content of that address. Content of it is added with R naught, and the result is stored in R naught register. Okay, this is indirect addressing mode. In the instruction, the address which is specified is the address of a memory location. In this indirect addressing through memory location, the address which is specified in the instruction gives the memory location that contains the actual address of the operand. It contains the address. It does not directly contain the operand. It contains the address of the operand. And the from that address, suppose this is address is B. So at B, the operand value is present. Okay, this is indirect addressing mode through memory location. Copy down this diagram. Okay, copy down this diagram. And this diagram also, which clearly tells what it is. This is the instruction. Content of A contains the address B and at B the operand value is present. Okay, so this is indirect addressing. You can observe here to access how many times the memory has to be accessed. I give the instruction. This is the instruction which is being executed in the processor. I access the address A. This value is passed to MDR, memory data register, and it reads this address and then again access memory to get the operand value. So 2 times the memory has to be accessed. Okay, so this is indirect addressing mode. Next, indirect addressing mode through registers. Same thing. What is the difference here is in the instruction and register value is given, not memory location. It is the register value. Okay, suppose R1 register. Okay, so R1 register contains the effective address or the actual address where the operand is present. Okay, so here is an example. Okay, here is an example. The instruction is add R1. This is the indirect addressing mode using the register. Okay, add the content of R1. So it is add R1 within the bracket, comma R0. Okay, so R1 contains the actual address where the operand is present. Okay, go to this memory location and access the instruction operand. Access the operand. Fine. So this is indirect addressing mode through registers. So the content of register contains the effective address, and the content of that address plus content of R0 is added as per this instruction, and the result is put within R0. Okay, this is indirect addressing through registers. Okay, how many references to the memory here? The instruction is already being executed. Okay, so in the instruction you see that R1, one of the operand is R1 within the parenthesis. So that means it is the effective address of the operand is given in R1 location. Okay, so access the memory, access the register. So B is the address of the memory where the operand is present. So access memory. Here only once the memory is accessed. Okay, both are registers which is used. If the bracket is not there, it is register addressing mode. The content of R1 and R0 are added. Okay, as there is parenthesis which is used, means the content of R1 contains the effective address of the operand. Okay, so this is indirect addressing mode. One more addressing mode is immediate addressing mode. It is an addressing mode which is simplest, you can say. So that is the operand value is directly mentioned in the instruction. Okay, operand value is directly or explicitly mentioned in the instruction itself. Okay, fine. So what it is I just give add 234 and R0, as it is the value which has to be directly taken. I put ash, which indicates it is immediate addressing mode. Okay, so here the 234 value is added with content of R0 and the result is stored in R0. Okay, the value is directly given, operand value is directly given in the instruction. Okay. Now, when I give this instruction, what is the addressing mode used? Here, the addressing mode for first operand is immediate addressing mode, and for the second operand, it is register addressing mode. Okay, so how many of our operands are there in the instruction? 2 operands or 3 operands? How many of our operands are there in the instruction? Each operand may be represented using a different addressing mode. Okay, as in this, it is the immediate addressing mode for the first operand and register addressing mode, which is used for the second operand. Okay, so you have seen 4 addressing modes as of now, that is register addressing mode, immediate addressing mode, direct addressing mode, and indirect addressing mode. Okay. Okay. You have seen 4 addressing modes: register addressing mode, immediate addressing mode, direct addressing mode, and indirect addressing mode. Okay, in indirect addressing mode, there are 2 types: indirect addressing mode through memory location and indirect addressing mode through registers. Fine. Any doubt? We'll just refresh once again. So addressing mode indicate the addressing modes is nothing but the various formats in which the operands or the memory of the operands, memory or location of the operands can be represented in an instruction. Okay, I say it is representation of operand or location of the operand. Okay, so operand means I'm telling it as an operand because in this example, in immediate addressing mode, I am directly giving, sorry, I'm directly giving the operand here, correct? I'm directly giving the operand value, correct? So it is directly the operand can be given, or the location where the operand is there can be given in the instruction. Fine. So there are different addressing modes, different ways. Now you have seen 4 ways. Okay. So the 4 ways which you have seen is direct addressing mode. Directly the operand value, register addressing mode, where the register value is directly given in the instruction. Okay. Register contains the operands directly in the instruction. Okay. So that is register addressing mode. In the register set, the values are mentioned. Next is immediate addressing mode. In immediate addressing mode, the value is mentioned in the instruction itself. The operand value is mentioned in the instruction itself. Okay. So in competitive exams, in GATE exams, they can give the instruction and ask you to identify which is the addressing mode, or they can ask you to find out what is the effective address of this particular operand. Okay, so effective address means the actual address of operand. Here the actual address of the operand are the second operand is R0. R0 is the location where the operand value is present. Correct. So we'll see a little more complex addressing modes whose effective address calculation can be asked in the GATE exams. Okay, so this is a very important topic, addressing modes. Fine. So the different ways of representing the operand or the location of the operand in an instruction. First is register addressing mode. Operand values are directly mentioned in the registers. Registers means always CPU registers. Okay, registers present in the processor, that is in the single that processor chip itself. Fine. So so here you have seen add instruction as an example. Similarly, move. I'm moving the content of R1 to R2. The content of R1 is moved to R2. Okay. How is the notation, transfer notation? Content of R1 is moved to R2. Okay, content of R1. R1's content means if the instruction, yes, it is R1, R1 is a register, R2 is another register. Whatever value is there in R1, 10 is moved to R2. I'm moving it using that instruction. Okay, it is copied. Movements, it is copied, not cut and paste. The value is copied to another register. Okay, this is register addressing mode. Next is immediate addressing mode. In the instruction itself, the operand value is mentioned directly. The operand value is specified explicitly, means directly in the instruction itself, the operand value is mentioned. Okay, so this is an example. Always we use hash to indicate that it is not a location, it is not an address. Okay, it is directly the operand value what is mentioned there. Okay, so instead of it is not the address field, it is directly the operand value what is mentioned there, and that is indicated by this hash symbol. Okay, this is indirect addressing mode, sorry, immediate addressing mode. In the instruction, directly the operand value is mentioned. Next is direct addressing mode. Here, direct addressing mode means directly the address of the location, the address of the operand is mentioned in the instruction. Okay, the effective address or the actual address of the operand is mentioned in the instruction itself directly. As I have told, example, add location A and R0. Okay, this is some location in memory. Okay, or add, I give F1 R0. F1 is another location in memory. I had told in the previous class that if it is mentioned like A, B, or location A, okay, location B, location C, anything, A, B, C, D, anything, okay, or location D, or it is F1, or directly X, okay, here X, or it is where 1, where 2, all these are locations, memory locations. Okay, all these are used for representing memory locations. Okay, not only this, according to the situation or according to the topic, okay, it can be like anything like sum. Okay, sum is a memory location. Any alphabets which other than starting with R followed by numbers, all these are register values. Okay, registers, CPU registers, all these are memory locations. Okay, so location A indicates it is a location in memory. So suppose this is location A and it contains 10. The content 10, the value 10 is added with R0 register. Okay, so the address of the operand, the effective address or the actual address of the operand is directly mentioned in the instruction. Okay, and in one fetch, in one memory access, you get the value. Fine, that is direct addressing mode. Indirect addressing mode, the value, the operand address is not directly mentioned in the instruction. There is an address, but it gives at that address location, it gives another address where the actual operand is present. Okay, this is indirect addressing mode. It is not the address which is given in instruction is not directly telling where the operand is present. It gives an address, and in that address the actual address is present. Okay, this is indirect addressing through memory location. Through memory location, yeah, in the instruction the address is given, which is a memory location address, and using that in the content of it gives the effective address or the actual address of operand. Okay, another addressing mode is indirect addressing through registers. Fine. So before going to it, you can ask if you have any doubts in indirect addressing mode through memory location. Through memory location. Okay, I have told how to represent it. The difference is that if I give add location A and R0, this is direct addressing, and I put within the bracket, means location A contains the effective address of the operand. Okay, location A alli address ide. ಆ address ಅಲ್ಲಿ operand value is present. Fine. This is addressing mode through memory location. Next, addressing mode through registers. Okay, through register. So here the register are the operand address is present in a register. Okay, and the content of that is the content of register R gives the actual address where the operand is present in memory. Okay, it gives the address of the memory location where the operand is actually present. Fine. Now you can see this example as I had told you. So add R1 comma R2. This is register addressing mode. Now within the bracket means R1 gives the effective address of an operand where the operand is present. Okay, so here in this example, add R1 is indirect addressing mode through registers. Okay, and R2 is register using register addressing mode. Okay, there are two operands. Eradu operand bere addressing modes is followed for both the operands. Okay, first operand is following indirect addressing mode through registers. Second operand is following register addressing mode. Okay, so we'll see the index addressing mode and relative addressing mode, auto increment and auto decrement addressing modes in the next class. Now as of now, any doubt you can just tell. Okay, copy down those examples also. Copy down those examples. So you can also copy down this move. Okay, move the R1 or R0 within the bracket means R0 contains the address of this operand which will be moved to R3 register. Okay, so how do you represent this notation? Content of R0 gives the address. Okay, gives the address of a location, and that address alliro content is moved to R3. Okay, this is indirect addressing mode. We will stop the class for today. If there is any doubt, you can ask me. Not audible. Not audible, Chandramouli. Not audible. Yes. Students, any doubt? Any doubt? Mohan?
No, ma'am.
Yes. Yash Kumar. Yash Kumar is there? Harshita is in your class. Harshita. Yes.
Ma'am.
Harshita, any doubt?
No, ma'am.
Kaushik C. Kaushik,
Yes, ma'am.
any doubt?
No, ma'am.
Okay. So there will be a quiz